Section 3 in Chapter 1 is where we're headed today. I have warned you on a couple of different occasions about how difficult Chapter 1 is, and I'll continue to do that. Today is not quite as long as Sections 1 and 2, but for some reason, I'm not exactly sure why. Maybe it is just many of your preparations in algebra during your high school years, but we're going to do factoring today to help us to solve equations, help us to break down complex rational expressions. So it's extremely helpful if you know how to factor. So like I said, it's not quite as long today, but factoring is a major source of frustration for many pre-calculus students. So let's get started. First, of course, a variable like x or y or t or any variable whatsoever, h, w is simply an alphabetical letter that stands for a number. Now, when you put letters and numbers and exponents together, we can get different kinds of expressions. A monomial is when you have just one term, 5x, one term, 3xy to the fourth, 12x hw to the fourth. These are all monomials. Even though they have many letters in them, they're all connected by multiplication or division, and that makes it just one term, okay? Mono meaning one. For any of you that have ever read C.S. Lewis's Chronicles of Narnia, the Voyage of the Dawn Treader, when that ship beaches on that remote island, and they see these very strange individuals that live on this island, and they were called monopods. Monopods were these type of creatures that only had one leg. Mono meaning one, okay? Binomial, of course, bi means two. These are all two-term things. This one is a binomial because that's one term, and this is one term connected by addition or subtraction. Trinomial has three terms, okay? Trinomials, okay? If you get more than that, more than three terms, we usually just call it a polynomial. Here's the general form of a polynomial. We like to put the powers of x in decreasing order. Here's the biggest power, the next biggest power. You see how they're going down to where there's no x's at all right? That's called descending order, going from the biggest powers down to the smallest. The alphabetical letters here are all real numbers. Remember, no imaginary numbers in pre-calc. The degree of this polynomial is the highest exponent. You're going to have some problems today in your homework dealing with what is the degree of a polynomial. It's the highest exponent, okay? Now, let's talk about various things you can do with polynomials. You should be able to add, subtract, multiply them. And that's going to bring us into, of course, factoring when we want to do the reverse. All right, so when you add polynomials, okay, we have a 2x squared and a negative 3x squared. You just collect those together. 2x squared and negative 3x squared, when the signs are different, you subtract and give it the sign of the biggest. So that would be a negative 1x squared. 5x plus 7x is 12x. Negative 3 and 8. Subtract and give it the sign of the biggest, it would be a positive 5. When you subtract polynomials, it's totally different. I have 2x squared plus 5x minus 3. Now I want to subtract a negative 3x squared, a 7x, and a positive 8. Did I have to write it up and down like this? No, I didn't have to write it up and down. I just wanted to make a point. When you subtract, by the distributive property, you've got to take that negative sign into all parts of the second one, okay? You could have written it horizontally, but then this would become a plus 3x squared, a minus 7x, and a minus 8. I'm going to do the same thing here. When I go to subtract these, the directions are to subtract. I must take the negative sign into the bottom. This becomes a plus, this becomes a minus, This becomes a minus. When I do them up and down, I like to put the little parentheses around the sign changes to remind myself that I have changed the sign. Now we can just add here, and we're going to get a negative 11. We're going to get a negative 7, and a positive 5 is a negative 2x. And here, 3 plus 2 simply makes 5x squared. And that is subtracting polynomials. All right, so a lot of things going on this page. Here we want to subtract, okay? And once again, to subtract, you can take a negative in on the bottom only. Becomes a negative 13x, a positive 2y, and a negative z. Okay, now you can collect terms. A 3z and a negative z is a positive 2z. A positive 2y and a negative 5y is a negative 3y. And a negative 13x and a 4x, you subtract, give it the sign the biggest, is a negative 9x. Okay? Over here we multiply. Many of you probably remember multiplying. The one thing from algebra you probably all remember is the FOIL technique on multiplying. 3x minus 4, 2x plus 7. Okay? When you're multiplying by FOIL, okay, multiplying by FOIL is simply doing the distributive property. So I'm going to take this times this, 3x times 2x is 6x squared. I'm going to take this times this, which is multiplying. First we did the first terms, 3x times 2x, letter F for first. Now we're doing the outer terms. O for outers, 3x times 7 is 21x. Then we do the inners. Negative 4 times 2 is negative 8x. So it's 21x and negative 8x. Should be able to do that. 21x and a negative 8x. You subtract and give it the sign of the biggest. Would be a positive 13x. Yeah? Okay? Then we do the last terms. Negative 4 times 7 is negative 28. The outers and the inners will most likely, most of the time, you can collect those. So I didn't write down 21x and I didn't write down negative 8x because I kept it up here and I'm saying 21x minus 8x is 13x. Okay? FOIL technique. Should be able to multiply up and down. 5x squared minus x minus 2 times 3x plus 4. Multiplying up and down. If you don't like multiplying up and down, write it horizontally and multiply like I did here by the distributive property, okay? But you can multiply up and down. So 4 times negative 2 is negative 8. 4 times negative x is negative 4x. 4 times 5x squared is 20x squared. Now I've got to take 3x times each one, okay? Now when you multiplied numbers back in grade school, you just automatically moved over one, okay? It's going to look like we're automatically moving over one, but it's more important to think about I must put it in the right column. 3x times negative 2 is a negative 6x. It's got to go in the x column. And there's the x column. The problems aren't going to always be this nice. So if you're multiplying up and down, be very careful about that. Negative 6x has to go in the x column. Negative 3x squared goes in the x squared column. And then I have 15x cubed here. And now I can add up. I have a negative 8. I have a negative 10x. I have a positive 17x squared. And I have 15x cubed. Okay? And that is multiplying up and down. How about the last one? The last one is 2x minus 3 squared. Now, we talked about exponents our last time together, okay? When we talked about exponents our last time together, I said there's kind of like a distributive property of exponents. You can take the 2 into both parts. If it's multiplying or dividing, you cannot take the 2 in there. Okay, one of the most common mistakes people make in algebra and pre-calculus. Cannot take a 2 in. You have to write it down twice because it's squaring. And then you simply multiply it by FOIL. 4x squared. Now, do the outers and the inners together, right? So the outers are negative 6x, the inners, negative 6x, negative 6x, and negative 6x makes negative 12x. And then your last term's positive 9, okay? That is horizontal multiplying by FOIL, okay? And you can't take the 2 in. All right, so that was a brief introduction to polynomials, adding, subtracting, and multiplying. And we're going to get dividing a little bit later on. Now we've got to talk about factoring, okay? I try to break factoring down into about 4, there's actually more than 4, but it's basically 4 rules, okay? I try to do it with some sense of order here. The first rule of factoring is to take out what is common. Why is it the first rule of factoring? Because, darn it, it's the most important. You have to take out what is common first. 5x minus 10y plus 15. 5x minus 10y plus 15. Look in all 3 parts. I see what's the same in all 3 parts. I see a 5. I can take a 5 out of all 3 parts. Dividing. I'm dividing 5 out of here. I'm left with an x. I'm left with a minus 2y. I'm left with a positive 3. Yes? That is taking out what is common. Okay? How about the next one? I'm not going to write that all down. Let's just look at it. Look what is common. I can take a negative out of both, and I can take a 12 out of both. So I'm going to take a negative 12 out of both. How many x's can I take out? I can take 2 x's out of this one, and I can take 2 out of that one. Okay? So I'm going to put an x squared. How many y's can I take out? I can take 4 out of this one, but I can't get 4 out of this one. I'll take 3 out of both of them. Notice, if you're looking for kind of a crutch or something to help you do these problems, you can always take the smallest of the exponent. I can take 2 x's and 3 y's. Now, what is left? What is left? If I divide negative 12 out of this, I have a 2. I took both x's out. They're gone. But I only took 3 y's out, so there's a y left. And now I took a negative 12 out of negative 36, so there's a plus 3. Yeah, you divide. Negative 12 out of negative 36 is a plus 3. I only took 2 x's out, so there are 4 left. And I took all 3 y's out, so there are no y's left. Okay, when you factor, it's division. It's division. I'm dividing negative 12 and the x's out of each one. Okay? All right. That is factoring what's common. You should always do that first. It's the absolute most important rule of factoring. Okay. Difference of 2 squares. All right? Difference of 2 squares is precisely what it says it is. A difference is the answer to a subtraction problem. So you must, if you're going to do difference of 2 squares, you must always have a subtraction problem. Difference means subtract. 2 squares. You must only have 2 terms. 2 terms, 2 terms, 2 terms, 2 terms. And they must be squares. X squared and 9 are both the squares. They're a square of an x and the square of a 3. Square of a 2x and the square of a 5. You with me? Okay, so it's got to be a difference, a subtraction problem. It's got to be 2 things, and they have to be square terms. All right? But you've got to remember to always try to do these in order. Okay? So even this is difference of 2 squares. You should mentally be asking yourself, can I first take anything common out of those 2? No, you can't. So go to rule 2. Is it the difference of two squares? X squared minus 9 is the difference of two squares. So I can break it down. I know that x times x will make x squared. I know that 3 times 3 makes 9. And to get a negative 9, one has to be positive and one negative. All right, now you can check your work. X times x is x squared. Your outers are negative 3x. Your inners are positive 3x. They go away, no middle term. And 3 times negative 3 is 9. Okay? These are called sum and difference factors because they're actually identical except for the plus and minus. And when you multiply them out, your outers and inners will go away. There's no middle term up there. Look at the next one. 4x squared minus 25. Anything common? You can't take anything out of 4 and 25, and there's only x's in that term. So there's nothing common. Difference of two squares. To get 4x squared, I have 2x and 2x. I have 5 and 5 plus and minus. Okay? If you break them down like that, you don't even have to check it. You know it's going to be right. All right? Next one, 2x squared minus 8. Now, we have something common. We have a 2. We can take out of both parts and get x squared minus 4, yes? Okay, remember, it's division. 2 taken out of 8 is not 6, darn it. You're dividing, okay? Now, this is not taken down as far as it'll go. This is difference of two squares. So copy the 2 straight down, and you have x and x, 2 and 2, plus minus. Yeah? Okay? How about the last one? X to the 4th minus 1. Nothing common. Difference of two squares? Yep. So now be careful. I have x squared and x squared, 1 and 1, plus and minus. And you say, great, I did it. Ha! But you're not finished. That one is still the difference of two squares. This one is not, you cannot do anything to this. You just copy it down. And now do difference of two squares here. X and x, 1 and 1, minus and plus. And you're finished. Okay? So we've done 2 rules of factoring. Take out what's common, the difference of two squares. All right? We come to the next rule of factoring, which probably is the hardest. We're going to do FOIL backwards. Okay? There are a lot of different rules you can employ to do FOIL backwards. X squared minus 6x plus 5. It's a little like difference of two squares, okay? In that you do some of the same thought process. But let's just go through the steps. You still have to say, is there anything common? No, you can't take an x out of, there's no x here. You can't take anything out of 5 and 6. Nothing common. Is it the difference of two squares? Don't be silly. There's 3 terms. You know there's 3 terms. It's rule 3, right? 3 terms, do rule 3. FOIL in reverse. I know that x times x makes x squared. Now, whatever you put here and here must multiply to give you 5. Must multiply to give you 5. I like to list them here. The only factors you have are 5 and 1, okay? So you know it's going to have to be a 5 and a 1. Now, let's be clear about something from the start. This one is an easy problem. This one is an easy problem because there is nothing in front of the x squared. When there's nothing in front of the x squared, the only choice you have is x and x. When there's numbers in front of the x squared, it's a whole other ball game, and it's much more interesting. That's why I say this is the part of factoring that really bugs people, okay? But there's a couple of rules. If you follow these rules, you will get these right. Here's the rule. Check out that sign and listen to what I'm about to say. I must find factors of 5 that add to 6. I'll say it again. You go by this sign. I must find factors of 5 that add up to 6. And well, we don't have much choice. It's 5 and 1. So we know we just put in a 5 and a 1. Okay? Because they must add to 6 because that's what the outers and inners do. 1x and 5x adds up to 6x. Now, you need to get a negative 6x. And you need to take 5 times 1 to get a positive 5. So to get 5 times 1 to be a positive 5, two numbers multiply to get a positive. They either have to both be negative or both positive. In this case, they're both negative so that you get a negative 6x in the middle. A lot going on here. Let's try the next one. This one is an easy one because there's nothing in front of the x squared. There's nothing common. It's not the difference of two squares. We put down 2 parentheses. We're going to do FOIL in reverse. We know it's x and x. Factors of 20 are 1 and 20, 2 and 10, 4 and 5. Okay? Follow the rule I just told you. The thought going through your brain right now should be, I must find factors of 20 that subtract to give me 1. I'll say it again. I must find factors of 20 that subtract to give me 1. Okay? Look at your factors. Which of those subtract to give you 1? 4 and 5. There it is. If you follow that rule, you can factor anything. Okay? I must find factors of 20 that subtract. You always go by that sign to give me 1. All right, now here comes the fun part. To take 4 times 5 and get 20, a negative 20, you've got to take a positive times a negative to get a negative. So one of these is positive and one is negative. Okay? And here's another little neat rule that works here. Okay, whatever this sign is, negative, goes with the bigger. Because when you add a positive and a negative, you subtract and give it the sign of the biggest. So this negative sign goes with either the 4x or the 5x. It goes with the bigger, should be here, and that's positive. You can check it. X times x is x squared. 4x and a negative 5x makes negative 1x, negative 20. Check. Okay? Let's do another one. 6x squared plus 7x plus 2. Okay? Anything common in all three? No. Difference of 2 squares, don't be silly. FOIL in reverse. This one is difficult because there's a number in front of the x squared. Okay? So you just simply, you can put x and x down, but you don't know if it's 6 and 1 or 2 and 3 to get a 6. All right? So list your factors. 2 and 1. 6 and 1, 2 and 3. Okay? Now, you know there's going to be an x and an x. Okay? So if you want to let a little room, I'm going to slip the x and the x in here, letting a little room. Okay? Remember that statement I told you a little bit ago about factors of 20 that subtract to give you this? It's kind of the same rule. You still have to look now at both factors to find combinations, still go by this sign. You want to find combinations that add up to 7. Catch that? It's the same rule, but you have to factor in both combinations here that are going to add up to 7. All right, so here we go. Here's what I mean by combinations. 2 times 6 is 12. 1 times 1 is 1. Do 12 and 1 add up to 7? No. 6 times 1 is 6. 2 times 1 is 2. Do 6 and 2 add up to 7? No, it adds up to 8. Ugh. 2 times 3 is 6. 1 times 2 is 2. Do 6 and 2 add up to 7? No. 2 times 2 is 4. 3 times 1 is 3. 4 and 3 add up to 7. Okay? You found it. 2 times 2 and 3 times 1. Now, when you find it that works, you find the combinations that work, pick one of your pairs and put circles around. I don't care if you pick 2 and 2 or 3 and 1. I don't care. But put a circle around one of the pairs, okay? All right, because 2 times 2 is 4, 3 times 1 is 3, and 4 and 3 add up to 7. The ones you circle always go in the outers. So 2, 2 in the outers. The 3 and the 1 go on the inners in here, but they flip. So this 3 goes here. This 1 goes here. I know it's a little complicated. Once you do a couple, it's really easy. It's just a couple of fundamental rules, all right? Now, we got to get the signs. 1 times 2 needs to be a positive. How do you get a positive? When you multiply, they're either both positive or both negative. But if you want to get a plus 7 in the middle, they have to be both positive. You can check your work, but it's going to work. 2x times 2 is 4x, 3x times 1 is 3x. That adds up to 7, and 1 times 2 is 2. Okay? The last one is another one just like this. Okay? Aha! Whoa! We have something common. A 2. Take a 2 out. Y squared minus 5y minus 6. If you didn't take that 2 out, you would be trying to find combinations of factors that subtract to give you 10. You could have done it. You could have done it, but it would have been a mess. It would have been very difficult, or it would have been like this one. Okay? All right, by taking the 2 out, we now have nothing in front of the y squared. So isn't it an easy one? Y and y? Yeah? It's easy. 3 and 2, 6 and 1. What is the thought going through your mind right now? When is this class over? No, that's not the thought. What is the thought going through your mind right now? I must find, not combinations, I must find factors of 6 that subtract to give me 5. 6 and 1 subtract to give me 5. Put them in. Okay, now you got to get the signs right. To get 6 times 1 to be a negative, 1 has to be positive, 1 negative. Remember the rule? Go to this sign. The negative sign goes with the bigger one. So the negative sign, 6y is bigger than 1y. So I'll put the negative with the 6 and the positive there. That is doing FOIL in reverse. One of the most challenging things you'll see in chapter 1. Okay? All right, so rule 4 is grouping. We're back to easy stuff. Grouping. 3x cubed minus x squared plus 6x minus 2. Okay? When you see 4 terms, it's almost a dead giveaway. It's grouping. Rule 4, 4 terms. You see there's a little method to my madness here. 4 terms, rule 4. Split it up like this. Don't put parentheses around it. Just draw squiggly lines in under it. And all you're doing now is taking out what's common in both parts. So take out what's common in the first part. I can take an x squared out. What's left? A 3x. And when you divide x squared out of x squared, 1 is left. Don't forget that. What can I take out over here? I can take a 2 out, right? I'm going to take a positive 2 out. What is left? 3x, 2 divided into 2, minus 1. Now you're not finished. What is now in both parts that you could take out? What is common in both parts? You see the 3x minus 1? I'm going to pull that whole thing out. And look what's left in the first part, an x squared, and in the second part, a plus 2. Okay? Is this difference of 2 squares? No way. It's a plus sign. It's not a difference. It's a 2, which is not a square. You're finished right there. Let's do another one. How about the second? Minus 9x cubed minus 3x squared plus 3x plus 1. 4 terms. Squiggle, squiggle. What can I take out of both terms here? I can take a negative sign, a 3, and 2x's. Yeah? So I'll take a negative 3x squared, and I'm left, when you divide a negative into a negative, that's a positive 3x left. Negative into negative is a positive 1. And look over here. You can't take anything out. It's just the 3x plus 1. And now you have a 3x plus 1 in both places. I'm going to take it out. And look what's left over here. When you get rid of the 3x plus 1, you have a negative 3x squared, and you have a plus 1. Okay? Once again, you can't do anything more to this because 1 and 3s are not squares. Okay? It's broken down as far as it'll go. Okay, last one. 2x cubed plus x squared minus 6x minus 3. Okay? Now, once again, 4 terms. Okay? Once again, 4 terms. And when you have 4 terms, it's almost a dead giveaway, right? That it's going to be factoring by grouping. So let's do that. Squiggle, squiggle. Out of the first group, x squared. That's what's left. Out of the second group, a negative 3. Now watch out. When you take a negative 3 out, you get a positive 2x and a positive 1. And now you can see there's a 2x plus 1 in both that you can pull out, and you're left with an x squared minus 3. Oh, if that was just a 4 or a 9 or a 25, you could do difference 2 squares. But because it's a 3, don't bother. I mean, technically, if you wanted to, you could do x minus root 3 and x plus root 3, right? But usually just let it alone is fine. Okay? Now, I said there's primarily 4 rules of factoring. I want you to be able to factor cubes also, okay? This, I guess, would be a 5th rule, all right? When you factor x cubed minus 1, okay? X cubed minus 1, or x cubed plus 125. There's a way you can do this. There are some real cute little rules, but you'd have to memorize them. And people are going to, what do you do with a rule? Most of the time, you just forget about it. It's much easier when you see cubes connected by a plus or a minus sign, just take the cube root of each. X minus 1. That's your first factor. X minus 1. So you have a factor. It's kind of like 24. Suppose I wanted you to break down 24. You say, well, I know 3 goes into it. Well, how do you find the other factor? Don't you then divide 3 into 24 and get 8, right? So I know that x minus 1, by taking the cube root of each part, I get a factor. And here comes the fun part. All you have to do now is divide that into that by long division, which I'm aware some of you guys hate with a passion. But then you're going to have to do it. Let's do long division. X into x cubed. Whatever you put up here and say x into x cubed is, you must take that times x to get x cubed. All right? And that's why I pushed the minus 1 way over. We have a little bit of work to do first. X into x cubed should be x squared. Because x squared times x is x cubed. X squared times 1 is a minus x squared. When you do long division, you draw the line and then you subtract. Up and down, subtract. Go back 15 minutes to the beginning of class. You have to subtract by taking the negative in on the bottom. Okay? These go away, I have an x squared. Okay? X into x squared is going to go a positive x because x times x is x squared. X times -1 is negative x. Draw the line. And when you subtract, you take the negative in on the bottom. These go away. Bring your x down. Now you're ready to bring the -1 down. How many times does x minus 1 go into x minus 1? One time, x minus 1, subtract, take the negative in, and you have no remainder. There is your answer. When you factor that, you get x minus 1 times x minus 1 times x squared plus x plus 1 will give you that. Okay, this long division, for some of you, is going to be your Achilles heel. You're going to hate it. All right, you got to practice this. And why am I going nuts on long division? Because we're going to come back and revisit long division in chapter 3. So I wanted you to get long division now. One more, 8x cubed, and move the 125 over. Take the cube root of both parts to get your first factor. 2x plus 5, cube root of 125. How many times does 2x go into 8x cubed? It should go 4x squared. Take the 4x squared times both parts is 8x cubed plus 20x squared. Draw the line, and when you subtract, you take a negative into both parts on the bottom. These go away. I have a negative 20x squared. Don't bring that down yet. Okay? 2x into negative 20x squared should go a negative 10. X into x squared be an x. Now take the negative 10x times both parts. Negative 20x squared and minus 50x. Subtract by taking a negative into the bottom. These go away. 50x plus 125. And how many times does 2x go into 50x? It would go plus 25 times both parts is 50x plus 125, negative in on the bottom. Both go away. There's no remainder. Here are your two factors. Okay? Massive section on factoring. Good luck with the homework.